Welcome, ladies and gentlemen, to another episode of the Research Solutions series on our YouTube channel. Today, we're diving into the fascinating world of weather, short-term atmospheric conditions at a specific time and place. In this lecture, we'll explore the dynamic nature of weather, its components, and how it's measured. We'll discuss how weather conditions can change from day to day or even hour to hour, influenced by factors like Earth's rotation, sun's radiation, and land-water distribution. We'll also delve into the concept of changing weather patterns, examining shifts in temperature, precipitation, wind patterns, humidity levels, and the frequency and intensity of extreme weather events. We'll discuss the factors driving these changes, from global warming and altered rainfall distribution to the intensification of extreme events and sea level rise. So, buckle up as we embark on this enlightening journey to understand the complex interplay between weather and our environment. Let's get started. What is the weather? Weather, which refers to the short-term atmospheric conditions at a specific time and place. Components includes variations in temperature, humidity, precipitation, wind speed and direction, atmospheric pressure, and visibility. Measurement: meteorologists use instruments like thermometers, barometers, anemometers, and satellites to monitor and measure these different aspects of the atmosphere. It's dynamic and influenced by Earth's rotation, sun's radiation, and land-water distribution. Weather conditions can change from day to day or even hour to hour. Common terms associated with weather include: 1. Temperature, a measure of how hot or cold the air. 2. Humidity, the amount of moisture in the air. 3. Precipitation, any form of water, liquid or solid, falling from the atmosphere to the Earth's surface, including rain, snow, sleet, and hail. 4. Wind speed and direction, the movement of air, measured in terms of speed and the direction from which it is blowing. 5. Cloud cover, the extent to which clouds obscure the sky. What are changing weather patterns? Definition: changing weather patterns refer to alterations in the typical weather conditions observed over a specific region or the entire planet over an extended period. Components include shifts in temperature, precipitation, wind patterns, humidity levels, and the frequency and intensity of extreme weather events. Some factors are given as: 1. Temperature changes. Global warming and rising average temperatures. Increased frequency of heat waves, occasional cold snaps. 2. Precipitation patterns. Altered rainfall distribution and intensity. More severe storms and prolonged droughts. 3. Extreme events. Intensification of hurricanes, cyclones, and typhoons. Storm surges, heavy rainfall, and flooding. 4. Shifts in wind patterns. Changes in atmospheric circulation. Impact on regional climates and weather conditions. 5. Sea level rise. Melting glaciers and polar ice caps. Thermal expansion of seawater. 6. Frequency of heat waves and cold snaps. Increased occurrence and intensity of heat waves. Unusual cold snaps in some regions. 7. Impacts on ecological systems. Disruptions to ecosystems and biodiversity. Altered behavior and distribution of plant and animal species. 8. Ocean currents and patterns. Influences on ocean currents. Changes in sea surface temperatures and marine ecosystems. 9. Monitoring and understanding. Use of climate models and satellite data. Essential for adapting to and mitigating climate change impacts. Climate and its factors. Definition: climate refers to the long-term patterns of temperature, humidity, wind, precipitation, and other atmospheric conditions in a particular region. Climate is influenced by various factors, including: solar radiation influences climate, varies with latitude, time, and day. Latitude, distance from equator, affects sunlight angle, impacting temperature. Altitude, higher elevation, lower temperatures, affects climate. Ocean currents redistribute heat globally, influence coastal climates. Wind patterns, global winds, e.g., trade winds, shape climate. Landforms, mountains and oceans impact climate through wind and precipitation. Human activities, fossil fuels, deforestation release greenhouse gases, contributing to climate change. What is climate change? Climate change refers to significant, long-term changes in the average temperature, weather patterns, and other climate parameters on Earth. Key aspects of climate change include global warming, overall increase in Earth's average surface temperature, driven by higher concentrations of greenhouse gases, changes in weather patterns, shifts in weather patterns due to climate change, increased frequency and intensity of extreme events, heat waves, droughts, floods, hurricanes, wildfires, melting ice and rising sea levels. Warming climate leads to melting glaciers and ice caps. Thermal expansion of seawater contributes to rising sea levels. Poses risks to coastal communities and ecosystems. Ocean acidification. Rising atmospheric CO2 levels lead to increased CO2 absorption by oceans. Causes ocean acidification. Detrimental effects on marine ecosystems, especially coral reefs and shell-forming organisms. Impacts on ecosystems. Climate change influences ecosystems and biodiversity. Alters distribution and behavior of plant and animal species. Some species face challenges in adaptation or risk extinction. Social and economic consequences. Profound impacts on human societies due to climate change. Disruptions to agriculture, changes in water availability. Increased health risks and challenges to infrastructure. What are climate change patterns? Climate change patterns refer to observable and measurable changes in long-term weather and climate conditions on Earth. Here are some key climate change patterns. Temperature changes. Earth's surface is experiencing widespread warming. More frequent heat waves and higher average temperatures. Extreme weather events. Increased frequency and intensity of storms, hurricanes, droughts, floods, and wildfires. Changes in precipitation distribution and intensity. Melting ice and glaciers. Reduction in glacier and ice cap extent and thickness. Accelerated melting of polar ice sheets and Arctic sea ice. Sea level rise. Rising sea levels from thermal expansion and melting ice. Elevated risk of coastal flooding and erosion. Ocean changes. Ocean warming causes coral bleaching and impacting marine ecosystems. Altered ocean currents and circulation patterns. Shifts in ecosystems. Changes in distribution and behavior of plant and animal species. Disruption of ecosystems and biodiversity. Ocean acidification. Increased ocean acidity due to carbon dioxide absorption. Negative impacts on marine life, particularly organisms with calcium carbonate shells. Changes in precipitation patterns. Altered rainfall and snowfall patterns. Increased drought risk in some regions and heavier precipitation in others. Changes in wind patterns. Global and regional wind pattern alterations. Shifts in location and intensity of trade winds and westerlies. Permafrost thaw. Thawing of Arctic and subarctic permafrost. Release of stored greenhouse gases, contributing to warming. Explore how altered weather patterns due to climate change affect different crops, leading to fluctuations in yield and quality. Altered weather patterns due to climate change can have profound effects on different crops, causing fluctuations in both yield and quality. Here's an exploration of how these changes impact various aspects of crop production. 1. Temperature sensitivity. Warmer temperatures. Positive impact. Some crops may benefit from extended growing seasons and increased heat, leading to higher yields in certain regions. Negative impact. For temperature-sensitive crops, excessive heat can accelerate growth, affecting the timing of critical developmental stages and leading to reduced yields and compromised quality. Heat stress. Crops like wheat, rice, and maize are sensitive to heat stress during flowering, causing poor pollination, reduced grain filling, and ultimately lower yields. Cold snaps. Frost-sensitive crops, such as fruits and certain vegetables, may experience damage during unseasonal cold snaps, impacting both yield and quality. 2. Changes in precipitation. Increased rainfall. Excessive rainfall can lead to waterlogging in poorly drained soils, negatively affecting root health, nutrient uptake, and ultimately reducing yields. Increased disease incidence, particularly fungal diseases, due to prolonged periods of high humidity. Drought conditions. Drought can significantly reduce crop yields by limiting water availability, hindering photosynthesis, and stunting plant growth. Water stress can lead to smaller fruit sizes, lower sugar content, and diminished overall crop quality. 3. Shifts in growing seasons. Phenological changes. Altered growing seasons may disrupt the synchronized relationships between crops and pollinators, affecting pollination success and fruit set. Crop varieties with specific temperature and photoperiod requirements may struggle to adapt to changing conditions. Extended growing periods. While longer growing seasons may provide opportunities for increased yields, they can also expose crops to prolonged periods of pest and disease pressure, affecting both yield and quality. 4. Carbon dioxide levels. CO2 fertilization effect. Increased atmospheric CO2 levels can stimulate photosynthesis in some crops, potentially leading to increased yields. However, the impact on quality, such as nutrient content and taste, may vary among different crops. Nutrient imbalances. Changes in nutrient availability due to altered CO2 levels can impact crop quality, affecting nutritional content and taste. 5. Pest and disease dynamics. Range expansion of pests. Warmer temperatures can facilitate the expansion of pests to new regions, leading to increased pressure on crops and potential yield losses. Changes in pest dynamics can also impact the quality of harvested crops. Increased disease incidence. Higher temperatures and altered humidity levels can create favorable conditions for the proliferation of crop diseases, affecting both yield and quality. Changes in disease prevalence may necessitate increased pesticide use, raising concerns about residues and environmental impacts. 6. Extreme weather events. Storms and hurricanes. Physical damage to crops, including lodging, breakage, and loss of fruit, leading to reduced yields and post-harvest losses. Soil erosion and nutrient runoff may impact soil fertility and crop quality. Wildfires. Direct damage from flames and heat can lead to crop loss, affecting both yield and quality. Smoke and ash from wildfires can impact air quality, further affecting crop health and quality. 7. Adaptation strategies. Crop selection and breeding. Developing and promoting crop varieties with traits such as drought resistance, heat tolerance, and pest resistance. Utilizing advanced breeding techniques to expedite the development of climate-resilient crops. Precision agriculture. Implementing precision irrigation systems and other technologies to optimize resource use and mitigate the impacts of water scarcity or excess. Using data analytics and satellite imagery for real-time monitoring of crop health, helping farmers make informed decisions. Diversification. Encouraging crop diversification to spread risk and enhance resilience to changing conditions. Exploring the cultivation of alternative crops that may be better suited to the evolving climate. Policy interventions. Implementing policies that incentivize and support sustainable agricultural practices. Investing in research and extension services to facilitate the adoption of climate-resilient technologies and practices. Conclusion. The complex challenge of climate change and weather impact on global crops requires comprehensive understanding and proactive strategies. Altered weather patterns threaten food security, urging urgent adaptation and mitigation measures. Documented temperature increase, extreme events, and precipitation shifts highlight crop production vulnerability. The multifaceted consequences, from temperature sensitivity to pest dynamics, underscore the critical need for proactive measures. Addressing these challenges is paramount for global food production sustainability, emphasizing the importance of a united global effort. Future recommendations. Research and innovation. 1. Allocate resources for research on climate-resilient crops and sustainable farming. 2. Foster collaboration between scientists, agronomists, and farmers for innovative solutions. Climate-smart agriculture practices. 1. Promote adoption of climate-smart practices for weather resilience. 2. Implement precision farming and data-driven tools for efficient resource use. Policy support. 1. Develop policies incentivizing sustainable agriculture and agroforestry. 2. Establish regulatory frameworks to reduce greenhouse gas emissions in agriculture. Capacity building and education. 1. Provide farmer training for climate adaptation. 2. Raise awareness about climate change's impacts and resilient practices. International collaboration. 1. Facilitate global collaboration to address climate challenges. 2. Share best practices for enhanced collective resilience. Ecosystem conservation. 1. Prioritize natural ecosystem conservation for climate mitigation. 2. Recognize ecosystems' vital role in providing essential services for agriculture. Diversification and crop rotation. 1. Encourage crop diversification and rotation for increased resilience. 2. Explore alternative crops suited to evolving climate conditions. Early warning systems. 1. Develop early warning systems for timely information on extreme events. 2. Enable proactive measures by providing advance notice to protect crops. As we draw to a close on this enlightening journey through the intricate world of weather and its impacts, we hope you've gained a deeper understanding of these complex phenomena. Weather is not just about today's forecast, it's a vital part of our ecosystem, influencing everything from agriculture to the distribution of species. We would like to express our gratitude for your time and interest in our Research Solutions series. Your curiosity fuels our mission to explore and understand our world. Stay tuned for more insightful episodes in our series. Until next time, keep exploring, stay curious, and continue learning. We look forward to seeing you in our next episode. Take care.